Why will I mind? Acha, you are going to ask me important questions. When is your exam, Mazia?
Next week.
Huh? Next week?
Next.
Oh, next week only. Okay. Acha, India time, there is, what time does your class start today? Like the previous class we had, na? 2 hours, that started at what time?
4:30.
4:30. For all of you? 4:30.
Yes, sir.
No, sir.
Yes, sir.
For me, it was 5:30 to
5:30. For all of you, it was 4:30, na? Okay, see. So tell me if you are okay with Saturday and Sunday. Oops. Saturday and Sunday. 4:30 to 5:30. And for Khalil, it will be 5:30 to 6:30. Are you okay with this time? For if like this to Saturday, Sunday? Math class. Mazia ka math class. Mamuna, what about you?
I'm fine, sir.
You're fine. What about others? All of you have math class?
So I have math class on Saturday, Sunday.
I have math class and maths. Okay. What about others? All of you, I think, have math class, no? Those who study.
No, sir, I don't.
You don't.
Don't have.
Yeah.
So me neither.
Okay. Mazia, when are you free?
Like, my school ends at 1 o'clock. After that, I'm free till tuition.
One request. Speak a bit loudly and tell me, can you take class on Friday? Friday you can take a class. लेकिन दिक्कत ये है, what if I do Friday? आपके यहाँ 4:30 बजता है तो हमारे यहाँ 7 बजता है, 2.5 घंटे का फर्क है. So if I start at 3:30.
Sir,
tell me.
Saturday, Sunday, we have math class from 6:30 to 8:30.
Mazia?
Sir, I have 6:30 to
When do you have? You have 4:30 to 6:30?
6:30 I have bio, 4:30 is
Oh, you are maths bio. Congratulations. You are maths bio. तब तो आपका तो बहुत क्लास होता होगा. Okay. Saturday, Sunday. Time ही नहीं है फिर आपके पास. Like this Friday only I am quite busy. Friday you don't have class. Oh, sorry. Friday तो आपको क्लास ही नहीं होता है. So see, Friday. Can you come? Your time. आप लोगों से नहीं पूछा जा रहा, आप लोगों से सिर्फ माजिया से पूछा जा रहा है, तो मत आ जाइएगा. माजिया.
Yes, sir. I can come.
You can come?
Yes.
Okay. Everyone can come or what?
No, sir. 1 p.m. to 2 p.m. is usually
Sir, I can come,
lunchtime.
sir.
1 p.m. to 2 p.m. is Maimuna what? Namaz time.
नहीं, नमाज के बाद we have lunch at 1 2 p.m. Like maximum 3 from 3 I'm free.
Actually, you are free from 3. At 3, like it will be very late for me. Actually, this Friday I have some work after Maghrib. So 3 will be like 5:30. 5:30 is exactly Maghrib here. Okay. Fine then.
Sir, can I have it on Friday? This time is okay for me. 1 p.m. to 2 p.m.
ठीक है, fine. दोनों में हम बता दे रहे हैं. ठीक है, दोनों में हम बता दे रहे हैं, like, but same things will be going on. Okay, so all of you, those who want to come, काम करते हैं आपसे. This is also, please remember, the Friday timing is tentative. I would say I can cancel it because I mean like अगर कुछ काम आ गया ना, because I have to work till like 5 or 6 है ना, for my PhD, for my internship and fellowships. So if there is some meeting and all with my team, then I can cancel this. Okay, like even before 5-10 minutes I will say that I can't do this because I have a meeting, क्योंकि ऐसा कभी कभी हो जाता, but it's rarity. So just keep that thing open. Otherwise I am saying Friday 1 p.m. to 2 p.m. आप लोग आ जाइए, or you come on Saturday 4:30 to 5:30. ठीक है, and this is the or situation. अब इसमें से इसमें आइए, and you have to come 4:30 to 5:30. ये तो आपको आना ही आना है on Sunday. Sunday works for you guys? Okay, माजिया का तो नहीं वर्क करेगा ना? माजिया, Sunday will work for you? No, Sunday will not work
It
for
works
you.
for me, sir.
आप बाकियों के लिए तो वर्क करेगा, माजिया के लिए नहीं करेगा.
Sir, I'm free on Monday and no, not Monday. Tuesday and Thursday. Other than your class, I don't have any other class on Tuesday and Thursday.
Sunday को आप फ्री नहीं है 4:30 to 5:30?
No, Sunday I'm free.
Sunday you're free ना? You're okay with this? Okay. I will watch recording. So sweet. तो एक काम करते हैं, माजिया, what I feel is that let's have a class, है ना? ये अब आप लोग के लिए ऑप्शन नहीं बचा, है ना? You have only one deal. Anyone watches Shark Tank? You know what Shark Tank is? एग्जाम के टाइम में क्या ही, अरे वाह सही है भाई, Shark Tank देख रहे लोग, वाह, इज लाइक माजिया इज आल्सो लाइक, हाँ सर Shark Tank देख रहे हैं. तो अब आपके पास एक ही ऑफर बचा है ना? For some inconsistency, I am out, and you have only one option. All of you will come, except Mazia. They will come on Saturday and Sunday, 4:30 to 5:30, and on Sunday also 4:30 to 5:30. Mazia, you only come on this time. Okay, Mazia? Because अगर एक बच्चा रहेगा, then I can tell whatever you have to learn from S&P block. And if you have multiple students, then I will take the request from all of the students कि क्या पढ़ना है क्या नहीं पढ़ना है. So that will take 2 hours. So I think I can complete the important portions for Mazia in 1 hour, and then on Saturday, Sunday. Okay, Mazia? All of you fine?
So
Do you have a deal?
what will these timings be converted in Oman timing? So this will be 5:30 to 6:30, right?
हाँ, ये आपका 5:30 से 6:30 होगा. सही.
Okay.
Works for all of you?
Yes.
Yes, sir.
So let me take a minute, and I will just inform Nishkarsh sir, है ना? So he may take care of the meetings and all. So on Friday, ये क्या टाइमिंग बोले हम इसको? रियाद टाइमिंग है ना ये? This is रियाद टाइमिंग, right?
Yes.
1 p.m. to 2 p.m. So this is done. Let us move back. And what we were learning about the why anything happens. Okay, why anything happens. So, and we said that anything happens inside the universe because to disperse the energy that is present inside the universe. So in the universe has a constant energy, a fixed amount of energy, and that energy is constantly dispersing around, and if it is not dispersing around any process that is happening and it is not dispersing the energy of universe, that means I will have to put in some kind of work, है ना? So that is why fridge में क्या होता है, you need some electricity, right? So for the fridge to work, you need some electricity, and you also need to cover the whole thing down, right? But what will happen if you have anything that is heated, it can easily transfer the heat, right? It is easily transfer the heat. You don't need any extra energy to flow the heat from heated body, higher temperature to colder temperature. But to reverse the thing, you have to do some work. So in the universe, if the energy is dispersing, that process will be a spontaneous process. Okay, a process that happens automatically. You don't need any work to do. So universe is isolated, and I can say anything happens if the entropy of universe will increase. That means the quantity which measures the energy dispersion is entropy, and hence the entropy will increase. Anything happens if the entropy of universe increases. Okay, anything happens if the entropy of universe increases. Now, this term, that is anything happens, there is a quantity that can measure it, that is known as the spontaneity. There's a specific term in science. So what does science do? Science takes very common words from your English language, whatever language you use. For example, system, then it carves a particular definition for system, and then it uses inside that sense. So for this, anything happens, we have a term which is known as spontaneity. Spontaneity. Okay, this is what is spontaneity? Spontaneity is a spontaneous process. Spontaneous process is an irreversible process and may only be reversed by some external agency. Important point to note down is that spontaneous doesn't mean fast. Okay, it does not mean fast. Please remember that. It does not mean fast. It can be fast, true, but it does not mean it is fast. It can be fast, and it can be slow also. Next is criteria for the spontaneous process. Now, what is the criteria that we have for a spontaneous process? Okay, so criteria for spontaneous processes. Criteria for spontaneous process. Criteria for spontaneous process is that number one, only one criteria is there. Entropy of universe should increase. So now we have to expand on this term, that is entropy. We will come back to the criteria for spontaneous process. We have just written one term, that is entropy of universe should increase. Let us expand on this entropy word. Entropy. So how will you think about entropy? Entropy is the measure of energy dispersal. The measure of energy dispersal in an isolated system. system. Next is that why I'm making many stars here, because this is something that your teacher will give you marks on when you write what is entropy. It is the measure of randomness. And I think this is the line that is present in CERT also, right? It is the measure of randomness. So please, if you get asked about entropy in examination, please write entropy is the measure of randomness, है ना? उसी में marks मिलेगा आप लोगों को, okay? That will give you marks. So entropy of we want to talk about the entropy of the universe, right? So I can say, first of all, entropy, it is denoted by S, है ना? We can have we would have used it any type of letter here, but we have used S, okay? S, and again increase and decrease, that means we are talking about change in entropy, है ना? So that means delta S of universe, this will be equal to the delta S of surrounding plus the delta S of system. And for a spontaneous process, delta S, and we can also write this as delta S total. I don't want to write the universe a lot of time. So delta S total should be greater than 0. Yes or no? Delta S total should be greater than 0. It means delta S of system plus surrounding should be greater than 0. Okay, should be greater than 0. Now let us try to quantify what is this delta S. Okay, what is this delta S? We'll talk about I hope no one has problem till here, right? Yes or no?
No, sir.
No, no. Okay. Simple thing, system plus surrounding, hai na? And we have also seen what is the criteria before. We're just writing that down. Okay, next is how to think about the entropy. We will compare this and we will have two situations. We are having two situations, okay? And here we are having ice. And here we are having water vapor, that is gas. This is vapor, okay? The temperature here is, the temperature will be 0 degrees Celsius, right? Temperature will be 0 degrees Celsius. And let us say that temperature here we have increased to 100,000 degrees Celsius. Okay. Then we added heat to it. We heated the system by Q amount of heat, and we heated the system by Q amount of heat. Okay, both of them we heated by Q amount of heat, So what will happen? There will be a change in temperature, right? There will be a change in temperature. Let us say that it went from 0 degrees Celsius to 100 degrees Celsius, and this will go from 1000 degrees Celsius to 1100 degrees Celsius. 1100 degrees Celsius. Now tell me about the dispersal of energy, okay? Tell me about the dispersal of energy, dispersal of energy. Where there will be more dispersal of energy, in the A case or the B case, in terms of change? What will happen to the A case? You can also think in terms of volume, है ना? कहाँ पे change in volume will be very high. So think about something is very concentrated from solid and it is going to gas, and some case B is gas and it is only going to gas only, right? Gas से gas में convert हो रहा है, and here we are converting solid to gas. So where there will be a huge change in volume, think in those terms. A or B? Okay, Maimuna, can you explain?
According to me, it's B, because there are more atomic vibrations in it.
But I'm talking about change now. बताइए 1000 degrees Celsius, and if I go 1100 degrees Celsius, what kind of change will be there in the volume? Will it be same as moving from solid to gas? There's a huge jump, na? If I'm going from solid to gas, there's a huge jump in energy dispersal. Yes or no?
Yes.
But if I'm going from gas to gas, then there is not much, right?
Yes.
All understood this? Yes or no, Amuna? Tell me.
Yes, I understand.
Understood this, right? So now again, energy dispersal. So we are talking about delta S, and we see that delta S, it is inversely proportional to the temperature. When the temperature of the system was low, the change in entropy was very high. If the temperature of the system was very high, the change in entropy was low. And in this delta S, it was directly proportional to what? It was directly proportional to the Q amount of heat that we are giving. And the, wait a second, this will be equal to now the Q amount of heat that we have been giving and the temperature, inversely proportional to the temperature. Because if I give more heat, then there will be a high energy dispersal. It will be taking more and more volume. And if the temperature is low, then the change is very high. Then the change in the entropy is going to be very high. That is why I can say delta S is equal to Q by T. Is this fine with everyone? Yes or no? Delta
Yes, sir.
S is equal to Q by T. No problem, guys?
No,
Yes.
sir.
Yes.
No problem. Okay, fine. Now, let us try to write a question and you guys will tell me. Comment. Whether entropy increases or decreases in following. So if it is increasing, that means delta S, it is going to be positive. If it is decreasing, delta S will be negative. You will say plus or minus, plus or minus. So in A we have ice melts to form water. बताइए entropy is increasing or decreasing? क्या हो रहा है?
Increasing, sir.
Increasing.
Increasing, all of you? Minashi, Mazia, Mehreen, Kazan, Yusra.
Yes.
Yes.
Delta S is equal to positive. B, here we have a reaction. Okay, yes, Yusra, correct. We have a reaction in which the hydrogen gas, we are dissociating the bond, we are breaking the bond and we are forming 2 moles of hydrogen atom gas. So now you tell me what is happening. Energy is, entropy is increasing or decreasing? In this case,
Decreasing.
and what about others? No idea? Acha, see, let us talk at, so we have always talked in terms of, I've explained this entropy in terms of the area or the volume that the energy is taking up. Yes or no? Right? There is a volume term that I have always mentioned, because whenever we are talking about the energy dispersal, that means we are talking that, but the amount of energy that we have, it should not be concentrated, it should be diluted, it should be wider apart, it should be dispersed. Yes, Khalil? Yes or no, Khalil?
Yes.
Now you tell me, if I have 1 mole of H2, what will be the volume? It will be taking how much volume?
One. Yeah, 22.
Okay. What if we have 2 moles of any gas? Then it will be taking how much volume?
44.8.
So what do you think? So I can say that all the energy is concentrated in 22.4, and this second case, all the energy is concentrated in 44.8 liters. Yes or no?
Yes.
Yes, sir.
So what do you think? Where is the energy dispersal happening? Where is the entropy increasing? It is increasing or decreasing? Tell me.
Increasing.
Dispersal of
Increasing.
Yeah. We are having an energy dispersal and the entropy is positive. Entropy is positive.
So I have a doubt.
How about the
So we learned that wait. No doubt. Yes.
So next is liquid crystallizes. Okay, I understand that this is something that you must not have learned in school, and entropy guy, like this conversation about entropy, but you can keep this in head, right? I hope it makes sense to you guys, and I, at least for me, the randomness part, and it's not like I'm just saying on my own, and I'm not saying on my own. Whatever I'm saying about the entropy, it has been documented. There are research articles that have been made on the teaching of entropy, how one should teach entropy. Okay, so even if you go to, you can read about this, but this is not the time to read about entropy. You should learn entropy, that's it. Okay, but when time comes, you can learn and read about entropy also. Have you seen this movie? No.
No, sir.
Tenet? No one. No one has heard also?
No, sir.
No. Acha. This
No.
is the Christopher Nolan's movie, like latest movie, Tenet. Acha, fine, no problem. So in that, it talks about entropy. Okay, so liquid crystallizes to form solid. Tell me, guys, delta S will be plus or minus?
Minus.
Minus. Negative. Delta S will be negative. Okay. Okay. So now we have two things. There are some things that is happening in the universe. For example, if I talk about the falling of a pen, right? If I talk about the falling of the pen, then there is not an energy dispersal, but rather there is a decrease in the energy of the system, right? There is a decrease in the energy of the system. And there is some things. So we can answer some of the things that happens in terms of energy. And for chemists, the energy is delta H, that is the heat exchange. And we can also talk about some things and tell the reason of anything that is happening in terms of delta S. Yes or no? Correct? You have two things, enthalpy. So if the energy is decreasing, that process can happen. If the entropy of that system is increasing, then also that can happen. So this is falling of pen. And this can be an example of the two blocks, A and B, with 100 degrees Celsius, and here we have 0 degrees Celsius. So these are the two examples. So when pen falls down, the energy is decreasing, and in this system, the entropy is increasing. Correct. But if I want to create a mathematical formula, so I can say that the total energy, we will talk about a new type of energy which will contain this term also, and it will take care of the enthalpy part, and it will also take care of the entropy part. So we are going to define a new state function which is going to consider these two things, and then we can use that particular property or that particular term in order to tell whether something can happen or something cannot, because now we have two things, delta H and delta S. We want to combine them. So if I want to combine them, and if I want to operate plus or minus or any sign here, arithmetic sign, then one thing we have to take care is the units. I hope you have learned this in the physics first chapter, unit, dimension, and measurement, that if A plus B is there, then A should have the same unit as that of B. Yes or no?
Yes.
Yes.
Sir. Yes. Sir.
Yes. Okay. Okay. Fine. Thank you. So we know that delta S is equal to what? So this has the joule, units of joule, and delta S is equal to Q upon T. So which has the units of joule Kelvin inverse. Yes or no?
Yes.
So what I can do, I can just multiply temperature here, and if I multiply the temperature, now this will also have the, if I multiply temperature here, that means Kelvin. So Kelvin can get cancelled out, and you will get the term that is consistent with the unit, that is joule. Yes or no? Correct?
Yes,
sir.
sir.
Okay. So now we can derive and we can formulate a equation. We can formulate an equation. Now, we have studied regarding stability, and we have always said that now both of these terms are, both of these delta H and T delta S are have the units of energy. So we can call both of these terms are energy. Both of these terms are energy. And we have been consistent in one form, and we have been saying that stability, it is inversely proportional to energy, right? It is inversely proportional to energy. Okay, so we want to formulate, and Gibbs was the chemist or scientist, you can say, who formulated this equation. So this is known as Gibbs free energy. Okay, so the free energy that we are talking about, the energy which is going to tell whether something will happen or not. So we are now combining both of these things. So he said that this will be equal to H minus T delta S. So H minus Ts, let us say H minus Ts. G is equal to H minus Ts. And why minus Ts? Because if this part is increasing, if the energy is increasing, then the enthalpy is also increasing, right? But if this part is increasing, we have to be consistent with this term. Stability is inversely proportional to energy, right? So if the enthalpy is increasing, that means energy is increasing, and then we are getting low stability. But if the entropy is increasing, then the free energy will be decreasing, right? If the entropy is increasing, the free energy will be decreasing. And if the energy is decreasing, stability will be increasing. Yes or no?
Yes.
So what do we want to make? We want to make a new formula which is consistent with our old idea of stability is inversely proportional to energy. But we are now defining a new type of energy, that is free energy. And we have written it is directly proportional to the enthalpy. So we know that if enthalpy is low, the free energy will be low. If the energy is low, then we will have stability. We will have high stability that is consistent. Next, we want to try this equation with entropy. So if entropy will increase, the energy will decrease, and if the energy will decrease, what will happen? The stability will increase. Okay, so I hope now you understand where this formula is coming from. It is combining the two factors that we have learned, which determines why anything happens, and it is combining it in such a form that is consistent with our old idea of stability is inversely proportional to energy, and hence G will be equal to H minus T delta S, and the delta G will be equal to delta H minus delta T S minus T delta S. Okay, because whenever you this is the product rule of differentiation. If you know, have you learned differentiation a bit? Differentiation पढ़ा आप लोगों ने?
Sir.
Yes, sir.
है ना, physics में you would have some differentiation. So product rule में यही होता है ना, take one thing as constant, differentiate the other thing, and what is this delta? It's just like D only. Yes or no? This is like large difference, this is small difference. Okay, but we will do everything at constant temperature. So we'll write at constant temperature. At constant temperature, the delta G at constant temperature, delta T will be equal to 0, and hence delta G will be equal to delta H minus T delta S. This whole term will become 0, because delta T is equal to 0. Now this is known as the Gibbs free energy. The G is known as the Gibbs free energy. Okay, and this is the equation that is going to determine whether anything is happening or it is not happening. Okay, now we will talk about the spontaneous process that we wrote a criteria, right? We wrote a criteria. Topic will be spontaneous process and delta G. So what should be the value of delta G if the process is going to be spontaneous? We are going to derive that whether it should be positive or negative. We know only one criteria, that is delta S total should be greater than 0. This is the only criteria for spontaneity. And we know that delta S total is going to be equal to, tell me guys, can you help me? Delta S will be equal to delta S of system plus delta S of system plus
Delta S of surrounding.
Surrounding.
very good. Thank you. Delta S of surrounding. Okay. Now I can also write this as delta S of total. This will be equal to, now let me tell you something. This is the system, okay? This is the system. And it is giving out some energy. Okay. It is giving out some energy. So I said that delta H of the system was equal to, let us say, minus 20 joules. How many joules? Minus 20 joules, because it was giving out energy. Everyone is fine with this, yes or no?
Yes.
Yes.
Okay. Then also I can say, what is happening to the surrounding? Surrounding is getting heat or it is losing heat? Surrounding is getting heat or losing heat?
So
Tell me. Getting heat. So I can say delta H of surrounding will be equal to 20 joules, because it is getting 20 joules of energy, yes or no?
No, sir. It will have its own energy first, sir. I think.
Energy नहीं, change है ना, delta H है ना.
Okay, sir. Yeah.
है ना? Make sense?
Yes, sir.
Okay. So it will be getting 20 joules of energy. Yes or no? All of you tell me.
Yes.
Can I generalize and
Yes.
write this as it is getting minus of delta H of system? Just see and tell me, does it make sense? Minus of minus 20 will be equal to 20 only. है ना? Make sense, all of you? Tell me.
Yes.
So now we have taken for when there is an exothermic process, that means system is giving out heat. Let us try this and let us talk about what will happen if the system is getting heat. So if the system is getting heat, surrounding is losing heat, then also the relationship will be inverse only. So we can say that this is a general thing. The delta H of surrounding will be equal to minus of delta H of system. Yes or no? Correct? Yes or no, guys?
Yes.
Yes, sir.
Yes. And I can say delta S of surrounding is equal to whatever heat that the surrounding has got divided by the temperature, Q by T, that we have already seen. Delta S is equal to Q by T. And the system and the surrounding is getting how much heat? It is getting the inverse of or the minus of the heat that is exchanged by the system. This is going to be our delta S surrounding. Yes or no? No problem, guys?
Yes.
No problem, na? I hope no problem. Delta S of system plus, now delta S of surrounding will be equal to minus of delta H of system by the temperature T. By the temperature T. Okay. Now what I will do, I will multiply the temperature on the whole equation. You will get T delta S total will be equal to T delta S of system minus the delta H of system. Yes or no? Right, guys?
Yes.
Any problem? Till now, no problem. Now what I'm going to do, I'm going to multiply the whole thing with minus 1. I will get minus of T delta S total, which will be equal to delta H of system minus T delta S of system. Yes or no? Tell me if you have any problem in this line.
No, sir.
No problem, right? Okay. Now I can also write this as, this whole thing is what? This whole thing is delta G Yes or no? Correct? Any problem?
No, sir.
No, no. We have seen here. Delta S is H minus T delta S. Sorry, system कही है ना? Delta H minus T delta S. Okay. Now we can talk about delta G, whether it should be positive or negative. Whether it should be positive or negative. So delta G is equal to minus of T delta S total. T delta S total. So what is the criteria for spontaneous? Delta S total. It should be positive. Then we have temperature, and temperature is always positive. Yes or no? Can the temperature be negative? Can the temperature be negative? हाँ सर, होता है सर, हमारे यहाँ तो -10 डिग्री सेल्सियस चला जाता है सर। कैसी बात कर रहे हैं आप? Just tell me, is temperature negative? Can the temperature be negative?
Yes, sir.
No, sir.
अब तो लड़ लीजिए आप लोग दोनों, है ना? मोहम्मद और मैमुना लड़ लीजिए। एक बोल रहा है यस सर टेम्परेचर नेगेटिव हो सकता है, एक बोल रही नहीं हो सकता है। गिव मी योर रीजंस। युसरा क्या कह रही थी आप बताइए? युसरा?
Yes, sir, it can be negative.
It can be negative. Very good. तो क्या पढ़ाया फिर हमने आप लोगों को? Oh God, states of matter. You guys have learned states of matter with me ना?
Yes, sir.
पढ़ा तो है आपने, बताया होगा फिर हमने आप लोगों को, तो हो ही नहीं सकता कि नहीं बताया हो। Listen, when I was talking about Charles' law, then we said na volume at -273 degrees Celsius is equal to 0, right? And that is why this degree Celsius scale was removed. Temperature is measured at its absolute scale, and the absolute temperature that you are going to measure na, degree Celsius is just a relative temperature. Absolute temperature is measured in Kelvin scale only, and in Kelvin scale you can never have anything that is less than 0. Temperature is only going to be positive. अब ये देखिए, like think logically, okay? Think logically. Those who are saying it can be negative. Is temperature a physical property that you are going to measure? Yes or no? बताइए, आप उसको measure कर सकते हैं ना? Can you measure temperature? Yes or no?
Yes, sir.
Yes, you can measure temperature. Okay, fine. You can measure temperature. Tell me something that you can measure other than temperature, that you can measure. उसके लिए device होना चाहिए that you can measure. Simple device that you can measure. Length? Yes or no? You can measure length? Tell
Yes,
me.
sir.
Okay. What about intensity of light? You can say now this light is more intense, this light is less intense. Yes or no?
Yes,
me.
sir.
Yes, sir.
Fine. You can measure mass. Yes or no?
Yes, sir.
Yes, sir.
है ना? So these things are similar to temperature, है ना? Physical quantities. Yes or no? Tell me.
Yes, sir.
अब बताइए, how can you measure something that is negative? If you are measuring something, it should be present, na? Like if, can you say, imagine saying length negative में आ रहा है मेरा. The length is negative, doesn't make sense, because if it is negative, then how are you measuring it? If length is 0, that means it is 0. You can't measure it. It is non-existent. 0, it is nothing, like there is nothing called 0. No, it is just non-existent. Then we say that this word non-existent, we have a mathematical term for that. It is known as 0, right? It is known as 0. So anything that you can measure will not be negative, because existence ही तो positive है. If it exists, that means it is positive. It is the limitation of the degree Celsius scale and the Fahrenheit scale that they show you negative temperatures. And we use this degree Celsius because it is easy and it is relatively, what I can say, the numbers are fine and it is more humane numbers rather than very accurate numbers, right? For example, Kelvin scale is very absolute, the temperature that you are measuring. So after minus 273 degrees Celsius, there is no temperature. You can't even go after minus 273 degrees Celsius because at that temperature, the volume becomes zero. Now the volume can never be zero, right? It can never be zero. There should be some gas is present, it should have some volume. So please remember, if there is anything that you can measure, that measurement will always be positive. It can never be negative. If it is negative, then yani ki wo hai hi nahi na. If something is negative, that means it is non-existent. But if you're measuring temperature, we are saying that some temperature is present. That means there is some temperature and it will have a positive value. That is why temperature is always positive. Never say degree Celsius ke liye koi baat kare, it's fine. But please from your head remove that the temperature can be negative. It can never be negative. Hai na? You don't take the degree Celsius scale with you. You hold the Kelvin scale always. You hold the Kelvin scale always. Okay, so the temperature is always positive. Okay, Muhammad and Yusra, is that fine? You think
Yes,
about
yes,
it. Okay,
sir.
ये तो भले ही आप लोगों ने बोल दिया, आप लोगों को 10वीं क्लास तक पढ़ाया जा रहा है कि डिग्री सेल्सियस होता है, नेगेटिव होता है, लेकिन थिंक अबाउट इट, रात के अंधेरे में बैठ के सोचिएगा आप लोग कि हम कैसे कोई चीज मेजर कर सकते हैं जो चीज नेगेटिव हो. अगर नेगेटिव यानी कि है ही नहीं, और अगर है ही नहीं तो हम मेजर कैसे कर रहे हैं? It's a complete paradox if someone says that temperature can be negative, है ना? The temperature can be negative. Utility का अलग किस्सा है. Like, okay, fine, you can utilize degree Celsius more effectively than Kelvin scale. No, but still, Kelvin is more supreme. It is more supreme than degree Celsius because it makes sense. Fine. So temperature is always positive. Hence, minus of T delta S. Minus of T delta S. This term, if this whole term is positive, then with the minus sign will be negative for spontaneous process. Okay, that is why delta G is equal to negative for spontaneous process. So we have come to the point where the delta G is negative for spontaneous process. Negative for spontaneous process. Now what we are going to do, we are going to write different cases, the effect of temperature on delta G. Okay, and this table is going to be very useful for you guys. And you will be making the table, don't worry. Effect of temperature on delta G. So we have here few terms. We have delta G. Sorry, delta H, delta S, the delta G, the reaction, and whether it will be exothermic or endothermic. Okay. So now I'm giving you some situations. Tell me. Okay. We'll have to see this. I'm writing this here. Keep this equation in mind. Delta G is equal to delta H minus T delta S. Okay, minus T delta S. Let us say the delta H is negative. Okay, delta H is negative. Delta S is positive. What will be the value of delta G? Positive or negative? Tell me, guys.
Negative, sir.
What about others?
Negative.
Negative, right? Yes or no? All of you?
Yes, sir.
Right? It will be negative. Hai? It doesn't matter what is the temperature. Even if the temperature is very low or very high, it is going to be negative because this is negative and this term it is positive. So positive, negative, the whole term will become negative. Temperature is always going to be positive. Hai? That is why this will be negative. And the reaction, it will be spontaneous at all temperatures. Right? At all temperatures. And this will be what? Exothermic. It will be exothermic. Let us say the delta H is positive, delta S is negative. What will be the value of delta G? Positive or negative? Yes, guys. What did you say?
Positive, sir.
Positive, no? It will be positive. And that is why this will be non-spontaneous because delta G is positive and hence this will be non-spontaneous at all temperature. Okay. And hence this will be endothermic. You will have to give heat for this reaction. You have to give heat for this reaction. Let us say if the delta H is negative, delta S is positive. Okay. अच्छा एक बात बताइए, can you see this? If delta H is negative, it is favorable, na? The energy should be low. Delta S is positive. Entropy should be high. And entropy should increase. Enthalpy should decrease. Correct? Yes or no? For anything to happen, for a spontaneous reaction, either the enthalpy should decrease, यानी energy या तो decrease करे, pen नीचे गिर जाए, है ना? Other than or else what should happen? The delta S should be positive. That means energy dispersal should be there. Entropy should increase. The energy should disperse from a concentrated medium to a very large medium. Yes or no?
Yes,
Can you
sir.
think in those terms, all of you?
Yes.
Yes. Okay. So now you tell me. In this case, what is happening? Which of the You sure you are saying something? No. Yes. Okay. Now in this third condition, you tell me which is favorable. The delta H is favorable. अच्छा wait a second. ये तो हमने उल्टा लिख दिया. Wait a second. वो तो दोनों को negative कर दीजिए आप. Delta H is favorable. Yes or no? Right?
Yes,
Because
sir.
energy is decreasing. What about others, guys? Razan, Yusra, Muhammad, Minashi, Marine, Khalil.
Yes.
Yes, sir.
Yes.
Enthalpy is favorable. What about entropy? Entropy is favorable or not favorable? Yes, tell me. Tell me. Entropy should increase or decrease for favorable condition? For
Should
spontaneous,
increase.
increase. Negative है यानी कि क्या हो रहा है? Decrease हो रहा है ना?
Yes, sir.
Yes or no? If the enthalpy is decreasing, then only it will be negative, na? That means final is less than the initial. Final is less than the initial, so it is negative. Okay. So in this case, we have two terms. Now, now you tell me. Here we have delta H. This is favorable. This is not favorable. This is not favorable. Then what do you think? This term, this is favorable. This is not favorable, unfavorable. So this term should be small or big? Tell me. The unfavorable term should be small or it should be big?
Small.
Small, all of you, yes or no?
Yes.
Yes, sir.
So to make it small, the temperature should be low or high? The temperature should be low or high? To make it favorable, to make it small, this should be small to make the process favorable. Now, if I want to make it small, द टेम्परेचर को क्या करना पड़ेगा भाई, कम करना पड़ेगा या ज्यादा करना पड़ेगा? व्हाट शुड बी द टेम्परेचर?
Decrease.
टेम्परेचर शुड बी स्मॉल ना, यस और नो?
Yes.
ऑल ऑफ यू एग्री?
Yes, sir.
All of you agree? Okay, that means this can be negative if we have low temperature. So we'll say spontaneous at low temperature, है ना? And then this will be what? It will be exo at low temperature. Then if you have, this is negative, this is also negative, and the delta G will be positive. If the unfavorable terms becomes very high, that means we are doing a reaction in very high temperature. So this will be non-spontaneous, non-spawn at high T, and this will be endo at high T. Okay, endo at high T. Now again, the next is, this is positive, this is also positive. Okay, both of these are positive. So we have delta G is equal to delta H minus T delta S. अब ये बताइए which is favorable? Delta H favorable है? Is the delta H favorable or it is unfavorable? सिर्फ डेल्टा एच देख के बताइए ना. डेल्टा एच इज पॉजिटिव. Delta H is positive, that means what is happening? We have to give energy, na? Yes or no?
Yes, sir.
Well, if the human is giving energy, that means he is doing something. That means it is not happening automatically. Correct?
Yes, sir.
All of you agree? Yes or no? What about others? Mehreen, Minashi, Mazia, Memuna?
Yes.
Okay, so this I can write delta H is unfavorable. And the entropy is increasing or decreasing? Tell me. Entropy is
Increasing.
increasing. Entropy is increasing. That means this is favorable. है ना? Yes or no?
Yes.
Yes, sir. Yes, sir.
So if it is favorable, then what do you want? We want the favorable term to be very high. Correct? Yes or no? We want this favorable term to be large, na?
Yes, sir.
So the temperature should be high. So this will be spontaneous at high temperature. That means this will be exo at high temperature. And if you have same conditions, positive, and if you are doing this reaction in a low temperature, then this will become, the delta G will be positive, and hence it will be non-spontaneous. So non-spawn at low temperature. This will be endo at low temperature. Okay. So just tell me, do you understand this chart, this table? Yes or no?
Yes, sir.
So you will just redo this thing, okay? You will redo. ना अपने से खुद से explain करके, okay? अच्छा, please don't memorize this. And ये तो memorize करने के लायक भी नहीं है, okay? So you think about this equation, delta G is equal to H minus T delta S, and then you just see, you put sign still here, and then you predict whether the delta G will be positive or negative at high temperature and low temperature, okay? At high temperature and low temperature, okay? So this is all about thermodynamics, okay? This is all about thermodynamics.